This is one of the examples of an application problem that we can solve with a rational equation. And it's funny, these problems, if you're ever watching late night comedy TV shows, you'll see this is the type of problem they will often make fun of. And if you read it aloud quickly, you can see why. Jogger begins her workout by jogging to the park a distance of 8 miles. She then jogs home at the same speed but along a different route. The return trip is 13 miles. Her time is 1 hour longer. Find her jogging speed and complete the accompanying chart and use it to find her jogging speed. Let x equal the jogging speed. Now, it can be a little bit crazy just reading it, but if you get used to this chart, what you need to know from this chart is distance equals rate times time, DRT. Distance equals rate times time. Now we could use this equation to solve for t, and to solve for t you would divide both sides by r, and you'd get that the time is the distance divided by the rate. Or we could use this to solve for the rate. If we needed to find the rate is going to be the distance divided by time. But both of those equations, those secondary equations, come from distance equals rate times time. Don't get overwhelmed with the problem. Break it down, draw a little sketch, make the chart, fill in, and see where it takes you. Let's start looking at some pieces here. What do we have? Jogger begins her workout by jogging to the park. You can see here to the right I've got a path drawn, it's green, to the park. Let me highlight that. Jogging to the park, a distance of 8 miles, right? And then she jogs home at the same speed, but a different route. And this return trip, the trip home, is 13 miles. So we see that the blue part is 13 miles. Her time is 1 hour longer. Let me jot this down. The return time is going to be the first trip, the trip to the park, plus 1 hour, right? The return time, we're going farther. We're going 13 miles at the same speed. So, of course, it'll be a longer time. But how much longer? The return time is going to be 1 hour longer. So the first trip, the rate, or the, I'm sorry, not the rate, the time that it takes to go to the park. So maybe we could say return time, time to get home. The time home is going to be the time to the park plus 1. Hopefully one of those two ways of saying this makes sense to you. But of course, when we look at it, that it's the same rate for both, and it's a longer route, then of course that return trip has to take longer. We're given that we should let x equal the jogging time, right? Let x equal the jogging time. That's the rate. So I'm going to let x equal the rate. And it's the same rate there and back. So the x is the same both ways. What I don't know is time. I've got distance and rate, but look at this. I can use this time equals distance divided by rate to get the time to the park and to get the time home from the park. 8 divided by, the distance 8 divided by x, or the distance 13 divided by x. Do you see how that would work? I can go ahead and unscratch these and you can see that that's correct. But hopefully you can see why it's 8 over x, 13 over x. All right, I'm going to erase the second part of that formula to create a little bit more space. Let's see about writing an equation now. And it's right here. Let me highlight what I mean by here. It's right here. Either of these two ways of saying it, but the time home is the time to the park plus 1. and would look like this. Time home is 13 over x. And that's equal to, it's one more than the time to the park. So it's 8 over x plus 1, and there's our equation. That's the hard part. From here, it's just apply what you should have gotten in the earlier sections, the actual solving a rational equation. But let's go ahead and solve this one because it's a good practice. I'm going to use the method of multiplying everything by the least common denominator. The least common denominator here is going to be an x. So I'm going to multiply 13 over x times x. I'm going to multiply 8 over x times x. And I'm going to multiply the 1 times x. I'm multiplying each piece by an x. And I would even recommend using a different color. Like you see I've done. I've used a pink color for each of those. Do you see what's going to happen next? Oh, this is the fun part. This is so neat to see. Those x's just go away because x over x is equal to 1, right? These x's go away. They divide out because x over x is equal to 1. And look at what's left, a nice linear equation. Nice linear equation means this should be easy to solve from here. We've got 13 equals 8 plus x. Subtract 8 from both sides, and we get that x is equal to 5. So it looks to me like the jogging speed, x, is 5. So the jogging speed is 5 miles per hour. X is 5 miles per hour. I hope that example makes a little bit more sense to you, regardless of what part might have been a challenge for you. These problems just take some practice. So if it didn't seem easy yet, keep practicing. Even hit that show me another example. Give me another chance at this, and practice it a few times until you get to where you feel it's really easy for you. Don't hesitate to contact me if you do have a question about this example or other examples. I'm happy to help out and help you understand each of the concepts and problems.